Hi to all. Today's topic is self-induction, right? That I am going to explain. Previously, we discussed about the Faraday's laws, Lenz's law, induced EMF across conductor which is moving in the magnetic field. Now, today's topic is self-induction. Self-induction and mutual induction. These topics I am going to explain. Then first of all, what is self-induction? Self-induction means what? For example, look at here very carefully, and this is a coil. It is a coil. Okay, coil means just you have to take a wire, insulated wire, copper wire. It is wound over a hollow cylinder, and this is a coil. Okay, and this is a battery. This has post terminal and N terminal. And there is a plug key, this is the plug key, and now when we close this plug key, the current in this coil will be increases, right? The current increases. For example, when we close this one, if the current increases at the rate of dI by dt, that means for every second the increasing current is dI by dt. Then when the current increases in this, the field generated by this coil also changes. When the field generated by this coil on its axis is mu naught Ni, the field proportional to current. Then when the current changes, when we close the plug key, the current increases to certain maximum value. During that, field also increases. When field increases, the flux increases. That flux generated, magnetic flux generated by this inductor link with the same coil. Due to that, some induced EMF generates in this. That is called as self-induction. That means due to the change in current, in this coil, okay? Due to the change in current in this coil, if the EMF induces, then that is called as self-induction. Self-induction means induction of EMF, the phenomenon of, I will write the translation, the phenomenon of generation of current, generation of or production of current in a current or EMF in a coil. How the current is generating in this coil? Due to change in current in it. This is called as self-induction. This is the definition of self-induction. Okay? Right. Self-induction. Okay? Now, on what factors this self-induction will depend? What happens? Once again I will explain. When we close this plug key, the current increases. When current increases, the field increases. Because this current coil behaves like magnet, and the field generated by that coil depends upon the current. When current changes, field changes, flux changes. The change in magnetic flux link with the same coil, right? Due to that, in this current and EMF induces, then that is called as self-induction. Self-induction. In this coil, current changes. In the same coil, EMF induces. Then that is called as self-induction. Now let us see the flux link with the coil. If this coil has N turns, if phi is the flux link with the if phi is the flux link with one loop or with each turn of coil, okay, then the magnetic flux linked with N turns, okay, then the magnetic flux link with n turns of coil. For example, if total turns are n turns of coil is what? With one turn phi is the flux, with n turns the flux is n phi. This flux depends upon current, because the flux depends upon the field depends upon the current, thus the flux depends upon the current. We know that already. The field proportional to current, then the flux proportional to field, because phi formula VA cos theta. Then the flux proportional to field proportional to current. That means the flux is also proportional to current. When we remove a proportionality, we will get a constant, that is L. Okay? What is L in this? What is L? L is a constant. Its name is self-inductance. Its name is self-inductance. Self-inductance of coil, or it is also called as coefficient of self-inductance. Coefficient of self-inductance. Coefficient of self-inductance. Okay, right. And now I want the L formula, self-inductance definition and its formula I want. Then for that purpose, let us see here. I will write the heading. Self-inductance. What is self-inductance? Okay, self-inductance definition I want to write. And then for that purpose, first we write the formula for the self-inductance. We know here n phi is equal to Li. N phi is equal to Li. From that we write L is equal to n phi by I. We write L is equal to n phi by I. This we write from the general equation. You know that n phi is equal to Li. Then from this, if I is 1 unit, if the current you take as 1 unit, then what happens to L? L is the n phi. That means the magnetic flux linked with a coil when unit current passes through it is called as is equal to self-inductance. Its definition is magnetic flux equal to, what is phi? Phi is the magnetic flux linked with one turn, n is the number of turns. Okay, right. Then we write like this, that is the magnetic flux. The magnetic flux link with a coil when 1 unit current passes through it. When 1 unit current passes through it. Is called as self-inductance. Is called as self-inductance. Okay? Right. This is the definition of self-inductance. The magnetic flux linked with a coil when unit current passes through it. That is called as self-inductance. Now, what is the SI unit of self-inductance? SI unit of L. On the name of Faraday, actually this electromagnetic induction phenomena found out are initially observed by the scientist Faraday and Henry. On the Henry name, its unit is there. That is, its unit is Henry. And symbol is capital H. Okay? Right. This is the SI unit of L. Henry. Henry. The symbol is H. Or we write capital H. This is about self-induction and self-inductance. Now, what is a inductor? Which is said to be inductor? Inductor means what? It's not conductor, it is a inductor, right? Inductor is nothing but it's a coil with self-inductance, a coil with high self-inductance, a coil with high self-inductance is called as inductor. Okay, it was very simple. And this is the inductor, and its inductance is L. If inductance is more, then induced EMF is also more. Right? Okay, take the screenshot and note the points. Okay, let us see our continuation topic, that is the self-induction we are discussing. In this first, what is self-induction and what is self-inductance, what is its unit, that we discussed. And the next topic is induced EMF in self-induction. Induced EMF in self-induction. That means this is, for example, one coil. This is one coil. In this, if I current passes through it, okay, this is the number of turns is N. N is the number of turns in the coil. Number of turns in coil. Okay, number of turns. Phi is the flux linked with each turn. Okay, which flux? It is a magnetic flux. Don't be confused. Okay, phi is the magnetic flux. Magnetic flux linked with each turn. Okay, each turn of coil. Then whenever the current changes, for example, if the current changes at the rate of di by dt in this, okay, that means change in current for every second is the di by dt through this inductor. Its self-inductance is L. Then we know the formula, that is according to Faraday's law, right? According to Faraday's law. What do you know the formula for induced EMF? That is induced EMF is equal to, yes, what is that? E is equal to, we know, that is minus N d phi by dt. The coil has N turns. Phi is the flux link with each turn. This we can write as E is equal to minus d by dt of N phi we can write, right? Okay. But we know N phi formula as minus d by dt of Li, because we know already, just now we discussed, that is N phi is equal to Li. We write it here, then we will get E is equal to minus L into dA by dt. This is the formula for induced EMF in self-induction. Okay, right. Induced EMF in self-induction. Then from this also we can write the L formula, right? L formula we can write as L is equal to minus E by di by dt we write. Okay, right. From this also we can write the L unit. L unit from above formula we can write. That is, induced EMF is unit is volt. This time goes to numerator. Time goes to numerator. Volt second per ampere, right? Volt second per ampere. This we write as, or simply we write as Henry also. Okay, right. Now this is the L unit. If you want to define L from this, we can also define. Okay, if di by dt is 1 unit, if di by dt is 1 unit, then what you write the L? L is equal to, if you want to write only magnitude, then we write E. Okay, that means induced EMF is equal to self-inductance when rate of change of current is 1 unit. The induced EMF equal to self-inductance when rate of change of current is 1 unit. That means induced EMF per unit rate of change of current is equal to self-inductance, right? The induced EMF, another definition, the induced EMF per unit rate of change of current, unit rate of change of current is called as self-inductance. Okay, this is another definition for the self-inductance. Any one definition you can remember, need not to remember the two definitions. Okay, this is the important formula. This is very important. Induced EMF is equal to minus L dI by dt. Okay, right. Next, you can take the screenshot and write it. I will explain one problem based on this. Okay, let us solve the problem. I will explain one problem, this one, and then you have to solve these two problems. That is homework. These are the two homework problems, and now I am going to solve the one example problem. What they gave in this? An inductor of inductance 5 Henry. What is an inductor? Inductor is nothing but a coil with large self-inductance. That is the solution. The inductance of a coil they gave as 5 Henry. Carries a steady current of 2 amperes. What carries? Steady current means constant current, 2 amperes. How can 50 volt self-induce? In this some constant current is passing. That is the 2 amperes. How can 50 volt self-induced EMF can be made to appear in the inductor? In this inductor, we want to induce 50 volt potential difference, EMF. Okay, how you can induce 50 volt EMF? Actually, when EMF induces in this, if the magnetic flux link with this coil changes, then EMF induces. But when magnetic flux link with it changes, if the current changes, then field changes, flux changes, in that EMF induces. That means how you can produce EMF 50 volts by changing the current. Then at what rate you have to change the current? That means indirectly we have to find out the dI by dt at here. It was very simple. We write the induced EMF according to Faraday's law, right? Induced EMF is minus N d5 dt, but in the self-induction we write as minus L dI by dt we write. We want to write only magnitude, we can write magnitude. Okay, and the magnitude of induced EMF I want to write that you take only plus, then induced EMF is 50 volts, that is equal to L is 5 Henry, then dI by dt. Right, what is the dI by dt? dI by dt is 510 then 10 ampere per second. Right, if the current changes at the rate of 10 ampere per second, then for every second 10 ampere current should be changed. Means starting if it is 0, after 1 second 10 ampere, after 1 more second 20 ampere, after 1 more second 30 ampere. For every second the change in current is 0 to 10, 10 to 20, 20 to 30, 30 to 40. Means for every second the current is changing by 10 ampere. If the rate of change of current is 10 ampere per second, if rate of change of current or if the current changes at the rate of 10 ampere per second, if current changes at the rate of 10 ampere per second, then induced EMF is equal to 50 volt, right? In order to generate the 50 volt, the current should be changed at the rate of 10 ampere per second. Okay, right. Now let us go for some homework problems. I will tell you what they gave in the question and what we have to find out. That I will write. You select the formula. What? A self-inductance of a coil having 200 turns. The number of turns in the coil is 200. and the self-inductance is 10 millihenry. This one milli convert into henries, therefore that you can 10 to the power of minus 3 henry, right? Self-inductance of a coil 200 turns, it has a self-inductance 10 millihenry. Calculate the magnetic flux through a cross section of the coil corresponding to the current of 4 milliamperes. When 4 milliampere current passes, that is a 4 milliampere is nothing but 4 into 10 to the power of minus 3 amperes. Then we have what we have to find out. First question is that the magnetic flux link with the coil, means that is the N phi. Flux link with one turn is phi, with n turns is n phi. N phi is equal to what? There is one formula is there for n phi. L they give, I they give. Okay. And then second question is that the flux link with each turn. Each turn is the phi. Then they are asking to find the phi also. Okay. There are the two questions. Okay. You try for it and write the answer in the comment box. If the rate of change of current is 4 ampere per second, yes, in this what they give, the rate of change of current means di by dt. It is a 4 ampere per second, right? Induces an EMF of 20 millivolts. 20 millivolts. This you change into volts. 10 to the power of minus 3 volts. And then what is the self-inductance of solenoid? That means capital L is equal to how much, right? Use the same formula. Right, you can try for the two questions and write the answer in the comment box. Okay, thank you for watching my lecture. If you have any doubt, you can write in the comment box, or otherwise you can contact in the WhatsApp. Right? Thank you.